Hi guys, welcome to my YouTube channel. I'm Arpita from Sri Venkateswara College of Engineering, Cybersecurity branch. Today topic is implement the process system calls. Introduction to process system call. Process system calls are essential for creating and managing process in a operating system. Key system call include fork, execute, wait, and process termination. These system calls allow for a certain execution, synchronization, and termination of process. Fork system call. The fork system call is used to create a new process, that is copy of calling process. It returns the process ID of the child process to the parent process and 0 to the child process. The child process gets a copy of parent process money file description and other resource. For child parent, there are two types. In fork, there are two types: child and parent. In child program, exit is conducted, but in parent program, main program means main program. It is wait. Exit system call. The exit system call is used to replay the current process image with a new program. It loads a new program into the current process memory space and starts its execution. The exit system call is commonly used after the fork to execute a different program in the child process. Wait system call. The wait system call is used by a parent process to wait for the termination of a child process. It suspends the parent process until the child process executes and returns the termination state of the child process. The wait system call allows and proper handling of child process termination. A call to wait block the calling process until one its child process execute or a single received. After child process terminates, parent considers it execute after wait system call instruction. Child process may terminate due to any of these. Its call exists, it return for main, it receive a single means from OS or other process or difficult action in terminate. Process termination. Process termination can occur voluntarily by calling the execute system call. Some operating systems do not allow child to execute its parents as terminate. If a process termination, that all the children must also be terminate. Cascading termination. All children, grandchild, and etc. are terminated. The termination is initialized by a operating system. The parent process may wait for terminate of a child process by using the wait system call. The call returns system information and paid for a terminated process. If no parent waiting did not invoke wait process is example. Proper cleanup and resource deallocation are essential during process termination to avoid memory lags. A process can also be terminated by the kernel due to a single error or signal. Process life cycle. A process starts with the certain of the initial process by the operating system. Process can create new process using the fork system call, leading to a hierarchy of parents and child process. The exit system call is used to load a new program into a process, changing its execution. Process communication. Inter-process communication (IPC) mechanisms such as pipes, shared memory, and signal are used for process to communicate. Process can share data and synchronize their action using IPC. Proper synchronization and coordination are crucial for multiple process applications. Process synchronization. Like Synchronization mechanism like connection variable are used to coordinate the execution of process. Synchronization ensures that process access shared resource it control and ordinary manner. Deadlock or race condition can occur without proper synchronization mechanisms. Process scheduling. The operating system schedule determines the order in which processes are executed on the CPU. Scheduling algorithm like a round-robin, property-based, or multi-level feedback quiz are used to allocate CPU time to process. Process control block PCB. PCB contains process state program, contains CPU register, memory management information, and other process-related data. Process state. The operating system transition process between state based on events like I/O, computation, CPU scheduling, and synchronization. Understanding process state is crucial or effective process management. Context switching. Context switching is the process of saving the current state of running process and loading the state of another process for execution. Efficiently context switching overhead and ensures smooth process transactions. Process certain to termination in unique process can terminate voluntarily by calling exit or due to a signal or error. Example, synchronia. The child process execute a different program using execute. Best practices. Proper error handling is essential when using process system call to handle unexpected failures. Security consideration. Proper input validation and continuation should be enforced to prevent security. Conclusion. Understanding how this system call works and their interacts is crucial for developing reliable and efficient applications. Thank you for watching my video.